All right, so now we're going to do slightly different centripetal acceleration. I'm going to get this thing oscillating back and forth around its y-axis. You'll notice I've just hung it from the spring, and I'm just getting it going back and forth on its spring there. So let me select accelerometer and gyroscope over here and start recording and see what we see. So you see the data developing here. What you're seeing happening in by the blue line here is that we have oscillations around the y-axis. So omega y is changing. That's the only one that's really doing much changing. At the same time, what you're seeing up here is that you have centripetal acceleration in the x direction. Let me hide the other two for now. And I'll stop this so we can analyze it. There we go. So what you're seeing here is that whenever you have a high angular velocity, you have a high acceleration. This is centripetal acceleration. When you have zero velocity, you have zero acceleration. And so, of course, what's happening, if you look over here, is that it's still spinning around the central axis. Okay, here, that's about the center, but the actual accelerometer is displaced in the x direction from that central axis. So whenever you have an omega, you expect this thing to have a positive acceleration in centripetal acceleration in the x direction, which is what you see right here. Okay, so in fact, you can do something interesting here. You can plot omega versus the acceleration using the parametric plot. So let's do that. So let's do on the acceleration. We'll put that on the vertical axis, and we want to measure the x component of acceleration. We want the y component of angular velocity, and here we can make a very interesting parametric plot. And so you see the overall shape of this thing is a parabola, because centripetal acceleration goes like omega squared r, and omega is changing, and it goes like omega squared. But interestingly enough, you see that when it's rotating in one direction, you have a slightly different offset from zero than when it's rotating back again. And remember, the part down here, that is when you have zero centripetal acceleration, so that is at the end points of its motion. So it's basically there, and then again there. So when the thing is at rest, that's when you get zero here, but depending if it's turning one way or the other, there's an offset from zero, which is very interesting. And I'll give you a hint, you can figure this out. It has to do with tangential acceleration, because the accelerometer is also not directly on the rotation axis in the z direction. So it's very interesting. You can really dig deeply into this data.